Hello students, today we are going to discuss about the numericals of electromagnetic induction. Earlier we have discussed some numericals and today the more numericals are to be discussed. The first numerical is a horizontal overhead power line carries a current of 90 ampere in east to west direction. What is the magnitude and direction of the magnetic field? Due to the current 1.5 meter below the line. Now come to the solution. The direction of current is east to west like this, and magnetic field to be found below 1.5 meter, and what will be the direction of it is south and north. We know that the magnetic field B is equal to mu 0 I upon 2 pi r, that is 2 mu 0 I upon 4 pi r. We know that mu 0 is equal to 4 pi into 10 raised to the power minus 7. Here I is given by 90 is 4 pi and r is 1.5 meter. 4 pi cross by 4 pi. So B is equal to 180 into 10 raised to the power minus 7 divided by 1.5. B is equal to 1.2 into 10 raised to the power minus 5 Tesla. We know that magnetic field is generated around the current carrying wire in the form of circular loop, and its direction is decided by the flow of current, and flow of current is east to west. Then the direction of magnetic field around this current carrying wire will be downward at the lower point and upward at the upper point of this wire in the figure. So at lower point its direction will be towards south, because according to the right hand rule, when we pick up the wire in our hand and thumb is in the direction of magnetic field, thumb is in the direction of current, then the tiltation of the fingers shows the magnetic field, so its direction will be towards south. Direction of magnetic field will be towards south. Numerical number second. The primary winding of a transformer has 500 turns, where its secondary has 5000 turns. The primary is connected to an AC supply of 20 volt, 50 hertz. What will be the output of secondary coil? Now come to the solution. We know that number of turns in secondary coil, the ratio of number of turns in secondary coil to the primary coil is equal to the EMF, induced EMF in secondary coil upon primary coil. So ES will be equal to NS upon NP into EP. It is equal to 5000 divided by 500 into 20, that is 200 volt. Secondary induced EMF in secondary coil, or we can say the output will be 200 volt. There is no change in frequency. The frequency remains the same. The next numerical is question number 3. A wire is shown in figure. Carries a current I ampere. The circular part has a radius small r. The magnetic field at the center will be. The diagram is given like this. Current is I, O is the center of the circle, and R is the given radius. R is from this point to this point. This is also R. This is point A and this is B. We know that these two lines are these two current carrying wires are passes through the center. So magnetic field due to these wire will be 0. Magnetic field due to AO and OB at the center will be 0. So the magnetic field at the center will only due to the 3/4 part of the circular loop. Magnetic field at the center will only 3/4 part of the loop. So B will be given by mu 0 I upon 2R into 3 by 4. That will be equal to 3 mu 0 I upon 8R. This is the result. This is the magnetic field at the center of the circular loop.